This graph was taken from Ian Plimer's book Heaven and Earth, published last year. Professor Plimer is somebody who doesn't believe we have a climate problem at all. And this graph is meant to show that the world stopped warming in 1998 and has been cooling ever since. This is a claim you see quite a bit on the internet. The trouble is that it's exactly the opposite of what experts tell us has actually been happening. So how can we work out who's right and who's wrong? This problem crops up all the time when you're trying to understand what climate science has discovered. Trying to figure out whether some statistical inference is true or false or half true. This little video is meant to help you sort that out. Looking a bit closer at the graph, you can see that it's actually a story of monthly mean temperature anomalies. That's to say, the difference between observed temperatures and some baseline temperature represented by the number 0. What you do to get this is to take daily temperature records from, say, weather stations, add them all up for a month, divide them by the number of days in the month, and stick them on the graph one after the other. The result will be a jagged line like this, because that's the way the climate system works. There's that much variability in it. There's the trend that Professor Plimer wants us to see. The question then is, well, there are two questions. One is, has he got the numbers right? And if we're satisfied about that, does the trend really exist? Now, obviously you can put any number of trends on a set of continuously varying quantities like this. But do they mean anything? This one here, for example, could be described like this. December 1996 started a trend which for 18 months raised the temperature 0.6 degrees. Well, is this more meaningful or less meaningful than Professor Plimer's trend? That's the question. But we know from the record itself that variation on this scale is absolutely normal for the climate system. And so a trend like that tells us something we already knew. What would count as a discovery is something that emerges from the noise of the climate variability record. When you look at it this way, a trend is a kind of pattern. Patterns are something that humans are very good at discovering in the chaos of experience. In fact, it's a great strength of our cognitive system. But, and this is an important point, what concerns scientists is not so much discovering them as discovering whether they have any meaning. This is a very accurate chart of global mean temperatures at monthly intervals going back 30 years. This is a composite made by the three leading climate monitoring centres plus satellite tropospheric temperature data. They're given different colours so you can see pretty much how they agree and disagree. Now, if we place the first graph on top, there isn't a very much disagreement. Basically, they coincide, so we can say that the data is probably pretty much all right. There's the 30-year trend for the entire record, and there's the 10-year trend that we're investigating. Now, Professor Plimer's claim could be put like this. He's saying that this trend ended there and was replaced by that one. In other words, it's a claim about something happening right about there, 1998. Well, 1998 was special. According to which record you consult, it was either the hottest or equal hottest year on the record. It was also the strongest El Niño year that's ever been known. So to claim that years since that record haven't been as hot as the record is hardly news. But Professor Plimer and the contrarians are claiming more than that. Of course, they're claiming that what we see is a downward trend since then. Here's the question. Is it justified to make such a claim by putting a line on the graph just where you want to? Well, the answer is no, it isn't, and here's why. This is what you see if instead of months you put years onto such a graph. You bundle the months up, 12 at a time, and put 1 point for each year. A trend is quite easy to see. However, notice this. The 9-year period 1977 to 85 is flat, and so is the 9-year period 81 to 89. Now, what about the contrarian's 9-year interval here? That's flat too. So what we can actually say is that you can show any trend you like by choosing an appropriate interval out of any continuously varying data set. Making claims based on inappropriate intervals in statistics is called cherry picking. It's a very, very common statistical fallacy, and it's a fallacy because for any system you can consider, there's an appropriate interval for drawing statistical inferences such as trends, and that interval depends on the actual behaviour of the system. Look at this pair of graphs, starting with the one on the left. They both represent the record over a decade from 4 independent monitoring centres, each given a different colour. The left one starts in 1998 and ends 2008. Of the 4 trend lines, 3 of them show that downward slope that so impressed Professor Plimer. However, now look at the right. 1998's been left out and 2009's been put in at the other end. Lo and behold, the trends are all rising. And what this tells us is that Professor Plimer's trend is dependent on having 1998 at the front of his record and on nothing else. In other words, it's a straight case of cherry picking. Here's another way to show the same thing. All the red data points on this chart show the 30-year record from 1968 to 1998, and including that hot year. The straight line is a linear regression. That's a mathematically derived trend from that 30-year data. Once we add the subsequent decade, they're the blue dots, and redraw the linear regression, it becomes that pink line, and you can see that it's actually rising. What that tells us is that the decade since 98 has been warming. And here's a set of monthly means going back to 1880, the same data sets, with trend lines written for the whole 140-year period and the last 30. And this is a clear demonstration that the rate of warming has accelerated during the last 30 years. So it can be the case that 98% of the world's mountain glaciers are melting, and yet a few can be growing. It can be drying in eastern Australia, and yet there can be some wet years. Such anomalies tell us nothing whatsoever about the underlying trend. No hurricane, no drought, no species extinction, no heat wave can ever be used to refute the trend of global warming, but neither can it be used to uphold it. What we are entitled to say, and it's a very different thing, is that if the trend exists, the probability of such events is changed accordingly. In other words, we can only ever know we were right by looking backwards, and that's just the way probabilities work. We use the confidence we get from doing that to look forwards, and that's the way science works. There's no other way, no better way. So don't let anyone tell you they can refute any claim of global science by citing singular anomalies. If they do that, they only show that they don't know what they're talking about.